Bismillahirrahmanirrahim. Now we continue with the last task, answer a network request. Okay, this is related with client server. For a single threaded process, okay, for a traditional single threaded process, since it's only have one processor, okay, a server will take very long time to fulfill a request from a client, okay, because it need to accomplish one client by one client, okay. So to overcome the problem, okay, we adopt a process creation method. So for process creation method, where server will create a process to fulfill a client request. So if there is another new client make a request, so another process will be created. Okay, however, process creation is heavyweight. Okay, we learn in chapter 3 to create a process, we need a physical and logical resources. Okay, while thread creation is lightweight because by default, threads share the memory and others operating system of the process to which they belong. Okay, so it can simplify code indirectly and increase efficiency where it is more efficient for us to use one process that contains multiple threads. Okay, so we look at this figure. Okay, let's explain the multi-threaded server architecture. Now in modern OS, okay, we apply multi-threaded server architecture, okay, rather than process creation method. Okay, so for a new client, when it made a request to server will create new thread to service the request. Okay, so if another new client make a request, so server will resume listening for additional client requests. Okay, right. So we continue back to the previous to this slide. Okay, so basically, kernel multi-threaded. Okay, so during a system boot time, several kernel threads are created. Okay, so each thread perform a specific task such as managing devices, memory management, and interrupt handling. Okay. Okay, that is for section 4.1.1. Okay, the motivation. So now we look to the benefits of multi-threaded in 4.1.2. Okay, number one is the benefits is responsiveness. Okay, so thread allow to continue execution if part of process is blocked. Okay, so for example, in our word processor, so let's say our spell checker stuck. Okay, we still allow to do auto save. Okay, so that is excuse me, what how thread allow continue execution if uh, its part of process is blocked. Okay. Okay. The second benefit is resource sharing. Okay. Um, so thread share resources of process. Okay. Such as code, data. Okay. File. Okay. So it is easier than shared memory or message passing. So we learn in chapter 3 for process to share its resource. Okay, it have a interprocesses communication mechanism, IPC. Okay, through shared memory or message passing. However, a programmer need to write the code explicitly. Okay. Okay, it's contrast to thread because thread share the resources within the thread share its resources, okay, within the process to which they belong. Okay, right. So the next benefit is economy. Thread creation is more cheaper than process creation. Okay, thread switching lower overhead than context switching. Okay, this is also has related with resource sharing since thread share the resources of the process to which they belong. Okay, so it is more cheaper for thread creation compared to process creation. Okay. Okay, the last benefit is scalability. Okay, so threads can take advantage of multi-core architecture, where threads may be running in parallel on different processing core. This is contrast with a single threaded process where it only can run on one processor. Okay, so regardless on how many processor they are available. Okay, okay. That's all for section 4.1. Okay, the overview of multi-threaded. Thank you for watching.